Okay, let's do a little bit of work with our calculator and evaluate. Remember, evaluate means to find the value of the given trig functions. It says here by first changing to radian measure, the radian measure to degree measure, and then putting it in your calculator directly in the radian mode. Well, you know what I went ahead and did on the top of the screen here. I took this angle pi over 6 and I converted that into degree measure. So I multiplied by 180 over pi. I crossed off the pi's, and 180 divided by 6 is a 30-degree angle. So when I'm asking you to find the cosine of 30 degrees, if your calculator is in the degree mode, remember, to get your calculator in the mode you wish, you have to select the mode key. And this is if you have a Texas Instrument graphing calculator, 8384. And in the third row, I'm asking you to decide whether you want it in radian or degree mode. So you got to arrow down and you got to hit enter on the one that you want to select. So if you would type the cosine of 30 degrees into your calculator, you would get 0.866. Let me remind you, because remember, I want you to feel trigonometry. I want you to get a gut check on this. So if I drew a 30-degree angle over here and dropped that perpendicular, remember that the cosine of this 30 degrees is equal to the side adjacent to the 30 degrees over the hypotenuse, or it's equal to x over r. And would you decide, if you want to agree with me, that this side right here is about, if you moved it over here and compared it to the hypotenuse, it's about 86% of, see this 0.866? It's 86% of the length of the whole hypotenuse. So that's where that comes from, remember. It's a ratio of the two sides. Now what I want you to do is I want you to put your calculator in the radian mode. So hit that mode key, go down 2 and hit enter when your cursor is over radians, and now I want you to type cosine of pi divided by 6, and it's also going to give you 0.866. So you need to be prepared to decide what mode to put your calculator in. If I express an angle in terms of pi, you know that this angle is in radians, so you'll hit the mode key and do the calculation by typing tangent times 7 pi divided by 3, close your parentheses, and when you do that, you're going to get an answer of 1.732. But in contrast, if I ask you to find the cosine of 30 degrees, you're going to put your calculator in the degree mode and type cosine 30, and it's going to give you 0.866. So be ready to be flexible and move backwards and forwards. All right, let's see if I can erase this over here. It looks like I can't erase that triangle. I'd love to, but I can't. I want to talk here about this angle of a little bit more than 1 radian, 1.37 radians. Come on over here. Here's 0 radians. Here's pi divided by 2. 3.14 divided by 2 is about 1.6. Here's 3.14. This is about 4.7, and over here you're at 6.28. So if I'm talking about an angle that is 1.371 radians, I'm talking about something close to 90 degrees. Maybe I'll do this in a different color. So talking about this angle being close to, again, the 90 degrees. The sine of this angle in blue is this side opposite, which is the y value, divided by the hypotenuse. Go ahead with your calculator in the radian mode and just type cosine 1.371. And again, notice this side opposite is pretty close to the length of the hypotenuse. So, I'm sorry. Way back a bit ago, and I'm not going to re-record this, I said, I might have said cosine or sine, I'm not sure. This was about cosine, and cosine is the side adjacent divided by the hypotenuse. So this side adjacent is small in comparison to the hypotenuse, so when you type this one, you get 0.198. Now let's refer to the sine of 1.371. That is the side opposite over the hypotenuse. Again, this side is pretty close to the length of this side, and so that ratio turns out to be 0.980, close to 1. Again, apologize for that. Let's look at this 3.76 radians. So here's 1.6 radians, here's 3.14, here's 4.7. So 3.76 is probably an angle over here, more than 180, somewhere maybe in the 200-ish. But when I ask you for the sine of that angle, my reference triangle for the sine of this angle says that I'm going to compare my y value, which is negative, to my r value. So would you type the sine of 3.76 on your calculator, and first, would you tell me if you get a negative answer? Because in the third quadrant, sine is negative. Also, the answer turns out to be 0.580. So this side right here is about 58% of the length of this side. That's what you're typing when you're typing the sine of 3.76. You're looking at an angle that's about 210 degrees, 180 plus maybe 30 or so, but it really is y over r, and in this third quadrant, y is negative. Where is 5? Well, let's see. Here's 4.7. Here's 6.28. So now we're speaking about an angle right over here. And so we're talking about 90, 180, 270, maybe in the vicinity of 300 degrees. But bottom line, what I really want to do now, I'm not going to bother with the triangle. I just want to remind you that cosine and secant are the only positive trig functions in the fourth quadrant. This is sine, so I want to know if you get a negative answer for that. So go ahead and type sine 5.21 and tell me if you get a negative 0.883. All right, let's go ahead now and talk about some previous work so we can apply it. So previously we said if we were working in degrees that the reference angle in the first quadrant was what we were always using for comparison purposes. In the second quadrant, we would take 180 degrees and subtract our reference angle. In the third quadrant, we'd take 180 degrees and add our reference angle. And then finally in the fourth quadrant, 360 degrees and subtract our reference angle. Remember, that was kind of a bow tie effect. I want to come on over here and I want to remind you that 0, 90, 180, 270, doing a lot of this, 360, but also, 180 is pi, and we refer to 180 quite a few times. So when I want to do the same process I did in the previous section, but I want to calculate an angle in radians, in the first quadrant, I'm still going to use a reference angle. And remember that because 90 degrees is pi over 2 and approximately 1.6, your reference angles are going to range in size. This is the size of an angle. Range in size between 0 and 1.6 instead of 0 and 90 degrees. That's going to feel real weird. Since 180 is the same thing as pi, the formula here will be pi minus our reference angle. And again, 180 is the same as pi plus our reference angle. And since 360 is the same as 2 pi, 2 minus our reference angle. I want to share with you that you should be preparing a note card. And on that note card, I would for sure have this table of formula statements. I might have a picture of the rectangular coordinate system and show myself 0, 90, 180, 270, 360. I'd show myself the pi over 2, the pi, the 3 pi over 2, the 2 pi. I might show myself that if I'm going to convert from degrees to radians, so for example, 120 degrees, you would multiply by pi over 180. I'd put that on my note card. If I'm going to go radians to degrees, I would multiply by 180 over pi. So prepare some information for yourself in terms of formulas and statements that we have learned so far about the signs of the trig functions. We'll come back in a minute and we'll work in finding the size of angles given the ratios, but these angles will be between 0 and 6.28.